Alright, guys, let's get started. So today this is week 9. We're having the second lesson, and today we're going to use the Google Colab to demonstrate the basic neural network, how it is done, how we form the neurons, and we complete several tasks and come up with the model which is suitable for training on simple data sets. So there are going to be two practices like that. We are going to cover the basics of building neural networks, and then we come to computer vision and demonstrate how to use the convolutional neural networks for our purposes. Alright, so for today, I hope you all guys know what Google Colab is. So we are going to use system, this one, just in Google and enter Colab. Like that, this link. Let me make it visible for you. And in Colab we have to sign with our real names. So enter your Google account. So you have to sign with Google Colab. After that, after you sign in, there is the file upload. You click file upload, and you'll have to upload a single file, which is the IPyNB. I attached this file in our week 9. So to load the file, right click on it and click Save Link As and save, and actually download all files that are included here. So there will be 3 CSV files and 1 IPyNB file. So to upload the file, you just drag and drop AI practice 1 field over here. We got the notebook, which already pre-filled. Some of you already worked with Colab. For others, if not, that the system is like the virtual machine provided by Google, and you are going to use for today we're going to use CPUs. But for the rest of our work, actually, we will need GPU. So Colab allows you to use the GPU. We will change the runtime and use the GPUs here. Okay, so let me make it a little bit larger, and I'll comment. So this this thing over here is called the linear unit or the basic neuron. That's what we are going to construct today. So this basic unit consists of the input. The input is X. Don't pay attention on this one. This one is just the bias. We are caring only about the X's. Okay, X values. There might be X0, X1, X2, and so on. So this input is just some column of numbers. Okay, the column of numbers. So we are talking about the table, and from the table the X input is just a column of numbers. So this number, let's simplify and talk about this single number. So this single number will be multiplied on this W. Okay, X times W plus B. Though this is the basic linear model, and here inside the this circle we see the plus. The plus is just the summation. So X times W plus B, we receive some kind of the output Y. So the the basic I would say Lego block for our purposes is just like that, the basic neuron. So let's say that we're talking of prediction, the calories given the amount of sugar. Okay, so here's the weight of 2.5 and the bias of 90, and we're going to just provide some input. Let's say that 5 grams of sugar gives us that many calories. So 5 times 2.5 plus 90, it will give us 102.5. So this is just the way how we present information. We give some input, the sugars, okay, and the neuron calculates for us the calories based on the weights, which the algorithm will determine by itself, and adding the bias, which also will be just a random number. After it calculates the result, then there might be some kind of the loss function, and based on this loss function, these weights will be transformed to more more suitable values. Okay. There might be multiple inputs, as we have said. So how many inputs do we have here? How many inputs? Why 8? We have x0, x1, and x2. We have 3 inputs over here. Again, don't pay attention on this one. This one is just some random number, which allows us to get away from the functions to some kind of the statistical relationships. Okay, so x0 times w0 plus x1 times w1 plus x2 times w2. All this will be summed, and the output is formed over here. So we can create this type of neural network, the basic neuron, with the help of the library which is called the TensorFlow. So there are 2 main libraries which are suitable for building neural networks in Python. The two most popular, I would say. The first one is called the TensorFlow, like that, TensorFlow, and from TensorFlow there are the framework of Keras, which allows constructing neural networks really easy, much easier than the PyTorch. PyTorch is more, there are more options inside, so it's quite harder to build neural network there, but you will have more options to customize it. So initially it was created with the TensorFlow, with the help of NVIDIA's. All NVIDIA cards support TensorFlow networks. PyTorch lastly also became very popular. So here remember to always include those two lines of code. Okay, from TensorFlow import Keras and from TensorFlow.Keras. Dot means that we are accessing the contents of the library. It's like the package in R. Okay, so here in Python we call it library. From TensorFlow Keras we import these layers. So remember those 2 key words. Do not use like the 1 layers or with the capital L. Just use it like we imported it. Okay, these names. So let's create a network with one linear unit. A bit like that. Here you see. All right, and to the left hand side. Okay, so our model will be created with the help of the Keras, and then we place dot, and after the dot there should be some kind of the help for us. And so far we haven't started the machine, so there is no help, but we can start the machine by playing this cell. Just running this cell, it will load those 2 libraries, and then it has the mistake. So model Keras, you haven't completed your syntax, but those 2 those 2 lines have been loaded previously. So if we place Keras over here and start writing something, there will be the list of possible inputs and we select the sequential from here. Okay? Keras sequential. In order for it to run, you click the play button. Your machine will be initializing. You'll have to wait a little bit. So far, if you see the green tick over there with the RAM and disk appeared, everything should be fine. So Keras sequential, you open the brackets, round brackets, and open the squared brackets inside. Why we need round brackets is for the function, and squared brackets is for the list. Okay, the list, the array, the several inputs which separated by comma. So the first line, second line, third line, and so on, they will all be the elements of the array, and they all be separated with a comma. Okay, so layers. Layers is this keyword. Okay, so we use this keyword layers, and from the layers there are a bunch of options that we might use, but we are going to use the dense again. I placed only 2 letters, and it already uses the hint. We are using this dense. Pay attention that you place dots, not commas, dots. Dot allows you to get inside the library to get the contents of the library. Layers.dense, and here is the number. The number is 1 over here because we're talking about the linear unit. We have the 1 output. This actually this one captures our result, this y. Okay, one output. And as soon as we are talking about the first layer, we'll have additional argument, which is placed only in the first layer of the neural network. And the additional argument is called the input underscore shape. Input shape. So input shape requires the argument to be as a list. Again, list in Python, square brackets. So we place square brackets inside and place the number which is required. So if we place 3, this will be our neuron, which is the same as presented here in our picture. So we build the neuron with 3 inputs and 1 output, like that. Okay, so the basic building block is this model. We're going to create more comprehensive neural networks, but the basic type of neuron is like that. We always need to maintain how many outputs we need and how many inputs we need. The key idea here is to input with the squared bracket. So the input should be a list. What will happen if we forget about the list? So let's say I delete those values and try to run. And it says we have over here integer object is not iterable. We cannot iterate over number. We have to iterate over the list of numbers. So this is the result that should be fixed with the list. Alright, so far we have created the neural network with 1 neuron. Let's run the second piece of code. This allows us to build plots. And here we came to our first task. We need to actually import this red wine CSV. The red wine CSV you can find over here. This is your red wine CSV. You have to download it, and inside the download folder there are 3 files. So red wine, fuel, and concrete. We are going to use all of those 3 files today. So on the left hand side There is of course command to load, but still the files are not very large. So on the left hand side over here you'll see the folder, okay, the icon with the folder. So click this icon, so like that, and there will be the files tab appears, and in the bottom side you will see some kind of the disk, okay. So just above that disk there is the area, the empty area, which grabs your drag and drop, okay. So drag and drop these 3 files over here. So if you're in the right place, drop files to upload it to the session appears, okay. So your 3 files will be in this folder like that. You got it? So 3 files, Redwine, Concrete and Fuel should be placed with drag and drop. So if you cannot upload, go to your downloads folder, because by default there is like the quick access. Do not use quick access, just go to the folder, to download folder, and drag and drop from there. Okay? Who needs help? Raise hands, please. Okay, so far we're good. Alright, so we downloaded the folder, and let me also show you. So there is, if we click over here, do not do that, just I'm showing. So here's like the regular file system of your virtual machine. It is like the Linux file system. You can see the same kind of file system on Android phones. So inside that file system there is the content tab, content folder, okay, content. So this is the folder which by default is used for Collab to load files. Okay, so if you are missed something, open this content folder and drag and drop files to this folder. Okay, content. Alright, so far I think we're good. So let's import Redwine CSV. To import the file we will need the pandas library. Pandas allows us, and again I'm running I just wrote import pandas on SPD and I run this cell. So once I run the cell, the pandas library is loaded, and then I can use the pd dot and can see the methods and functions that are built inside. And we are going to use the read CSV method, and inside the read CSV we use this name of file redwine.csv. Okay, so to read it we have to read it to some kind of the variable, and let's name the variable red_mark_wine, like that. So redwine will be the read CSV. And to make sure that we read everything correctly, redwine.head will be our line of code. So for me, I read it correctly, and we can see the table. This table contains several thousand of rows, maybe 1.6 thousand of rows, and there are several columns. Our task is to understand how many are there. So how can we understand how many are there? Again, on the left hand side you'll see some kind of the X inside the curly brackets. So you can click here on the X, and there is the variables tab. It shows all the variables inside. So the red wine, if it loaded correctly, you will see that the shape of that 1000, almost 1600 rows and 12 columns inside. Okay, the X over here. We click, wait like 1-2 seconds, and it will show you the shape. So like we did, red underscore wine is our data set, and after the data set, if we click, if we place dot, there are also the methods which can be applied to the red wine. So our task is to understand what is the shape. Okay, what is the shape? Red wine dot, and here we select the shape. This is the property shape. Okay, we run the cell and we can see two numbers appeared. Let me return red wine dot shape. So our task will be later on. Our task will be to work with this data set. Okay, this data set contains the information about wine quality. This is the last column. It has the quality of some kind of the ranking. Okay, and there are the bunch of variables which describe the wine. Okay, so let's again, if you have questions, raise hands, I'll come to you. All right, so here is what we need. We need to find out what is the input shape. Remember, we have created the neuron over here, and we had this input shape parameter inside the layers dense. Okay, input shape over here contained 3 values. For example, it might contain sugar, it might contain fiber, and something else. Okay, the 3 inputs. How many inputs will be considering our table? If we see the shape of this table is like that. So how many inputs? Anyone? What is the input shape here? How many columns? 12? No, not 12. Why not 12? The input shape, the shape of the data set and the input shape are different things. Okay, the input shape has only X variables inside. Only X variables. The table shape shows how many rows and how many columns there are. So we predict the last column, the quality. So the rest should be X's. And the input shape should be 11 in this case. Okay? So here we uncomment that, and input shape will be our red wine shape. Red wine shape. And we can see that if we type like this, we are going to receive 2 numbers. So we need to access to the first number. Why first number? Because unlike R, in Python we are starting indexing with 0. So the 1599 will be 0 and 12 will be 1. So we access to this 12. Red wine shape 1 returns us the number 12. And as soon as we know that we have to get rid of the last column, here will be our result 11. Again, we have to remember that input shape should be list. It should be in the squared brackets. So let's place it inside the squared bracket, like that. Okay? So this is your input shape. And using this input shape, we will create the model, define a linear model appropriate to this task. So let's just copy. Let's just copy. Control C, Control V works. So this is our. What should be changed over here? What should be placed? Let's check our variables tab, and inside the variable tab we can see that there is like three, okay, input shape, one item, and this is the variable which stores inside the memory. This variable will have the number 11 inside. So we do like that. Input shape equals input shape. Okay? Very useful thing. Now have a minute in understanding if we run that like that. So our next task is look at the weights. Okay, we have the model dot something. So try to understand how to extract weights of the model. So if you place model dot, you'll see the list, and you need to find out the command that extracts weights. Try to find it. A little hint: you should look at this. Should look at these weights. And once you place the correct one, print your W and B. How to print anything? We just may create the WB and then run this cell. To create a cell, drag your move your mouse somewhere in the middle of the previous cell, and there will be appeared like plus code or plus text. Okay, so you add plus code, and there will be extra cell for the code to come. Stop the recording. Okay, so we have to look at the weights, and the weights of the model will be W weights, like that. Model.weights. And then if we print WB, we will see two arrays or two lists. This is the first array and this is the second array. So the second array bias is just 0. And the first array contains 11 inputs. These 11 inputs are the numbers which will be multiplied on each input. What does it mean, input? Input is our table. So fixed acidity will be multiplied by this number 0.42, and this last number minus 0.47 will be multiplied by the alcohol, the last column of input shape, like that. These are the weights of untrained models, so they are random. You might have different numbers inside. Don't worry about that, because once we train the model, the weights will be close between the models that we trained. Okay, let's move on. So here are some kind of the graph, and all graphs might be different. Don't pay attention to how the graph looks. Okay, the graph should appear, but the line might be completely different because it is just random numbers generated. We haven't trained the model yet. If you see the graph, just play this cell. If you see the graph, so you'll see something like some line. Okay, so next thing happens when we have several neurons inside. Before that, we have only one summation. So now we have two summations. We have two inputs, x0 and x1. They comes with some kind of weights and biases. They sum up, and we have the outputs, which are like two possible outputs. What? The one? This one represents the layer. X0, X1, and 1. So this one is the random bias which comes to the model. Because if we remove this bias, this will be the determined function. So we have to add some random numbers to capture statistical model. Not the function, but the statistical model. And that allows us to find the proper the generalization property of the model. So this is the picture with the layer. There is one layer containing two neurons. And there are different relationships. They might not be linear relationships. So here is the parabolic or quadratic relationship, and to capture those, we have to change the summation to some kind non-linear function inside. And here is the most common rectified function, which changes negative values to 0 and do not touch the positive values. So it leaves the positive values alone, but if there are negative values of weights, it just turns it to 0. So a very useful activation function which allows us to change linear relationship to non-linear relationship. And here how we look at it. Okay, instead of summation, there is the rectified linear function. Okay, next point is when we stack those different layers. So how many inputs do we have here? 2 inputs. Nice. How many neurons do we have in the first layer? 4. And in the second layer? 3. Nice. And how many layers do we have? No, how many layers? No. This is the first hidden layer, this is the second hidden layer. And this is yes. We have 3 hidden layers here. And one of them is linear. The last output linear function is the summation. It doesn't have any ReLUs inside. So it is just the linear output. So let's create the function like this with the fully connected network. So we're going to build the model 4-3-1 dense. 4-3-1 dense. What does it mean? We have to maintain 4 neurons, 4 units in the first layer, 3 units in the second layer, and the 1 output layer. Okay, I'm just again model Keras sequential. It is the same throughout. Let me check the recording is on. Yeah, model Keras sequential. Remember that we have list. List elements should be separated with commas. So always place commas. layers.dense, the first one contains 4. As long as we have the activation function, we can place the activation function over here. Activation equals to rectified linear unit, ReLU. And for the first layer, we also need the input shape. Remember, on the picture, input shape was 2. We have only 2 inputs. Okay? So this is the input shape. So you should see something like that. And don't forget to place comma after that, because we are going to create another layer. We copy that. We copy that. Place here. Place here. So what should be changed in the second layer? Here should be 3, here should be 1. What about activation? Here activation is okay, but here activation we do not need any. What about input shape? Here we do not need input shape, and here we do not need input shape either. Why so? Yeah. So this is the output, will be the input shape for the second layer. And 3 will be the input shape for the first one. Okay? Don't forget to place commas. It's okay if you leave the comma over here, it's alright. So just remember, so each line should be with comma. Let me check if it can be run. Run. Yeah. So the code works. Now remember how we activation. So let's say that you create again the layer. Don't write it. I'm just making your layers.dense. And inside, if we stop the mouse, we will see the units, and then we will see this activation. Okay, so if you don't know, just copy from here. All right. If everything all right, your code should be ticked with green tick. All right. Next, we have to load concrete. We know already how to load it. We do not need to import pandas as long as we have already imported that. So here was our here were our 3 lines of code. We don't need the first one. We already inputted it. But concrete here should be changed. Like that. And check that your code works. Again, check the input shape. And what? You already have this code. Stop the recording. Continue. So once we loaded the concrete, we can have the same kind of code for input shape. Input shape will be concrete shape dot concrete.shape. Remember that this function returns 2 numbers, so we need the number 1 over here and minus 1. So how many actually columns do we have? How many columns? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 columns. So the compressive strength, the last column will be our y variable. We're going to predict the compressive strength of concrete based on those numbers. So input shape will be 9 minus 1 is 8. Yes. So concrete shape 1 return you 9. Let's check whether it returns you 9 over here. So like that. It returns 9. And you need 1. 1 less. Okay? You need 8. Now we have the task. We need to create a model with 3 hidden layers. 3 hidden layers. Okay? Each having 520 units with ReLU activation. And after that we need to include output layer, 1 unit, no activation. Okay? So you have to create a network like we did, like we shaped those network for our 431. So now we have to create 3 hidden layers with 512 inputs inside. How many layers do we have here? How many hidden layers do we have? Hidden layers is 2, 1 and 2. These are hidden. This is the output layer. Now we have to create a neural network with 3 hidden layers, 1 output. Inside we have 512. We have activations ReLU and the input shape for our concrete problem. Do you understand? If you understand, do! Yeah, you have to create something like 512, 512, 512, and 1. Like that. 3 hidden and 1 output. So change those values. So you need to form the input shape. What is the input shape? It's your input shape because we already created that. We have extra third layer like that, and we have 512 inputs and 1 output like that. Nice. It's the same, just copy and change a couple of numbers. So we are just building those networks with specific architecture, okay? Pay attention to this activation equals to ReLU. This activation equals ReLU can be placed outside the dense layer and placed as the separate layer, okay? How can we do that? How can we place the activation ReLU to the separate layer? So first of all, I just copy. Rewrite these to use activation layers. Okay? So rewrite these to use activation layers. between each of those layers there are extra space, and we just create from the layers dot, what should we choose here? Separate activation layers. Look, we have activation over here. So layers dot activation. What should we put inside? We should put inside the same RHEL as here. And once we've done that, we remove this activation from here. Okay? Let's remove activation from here and remove activation from here, and just copy this as our separate layers, like that. So generally, when we build neural networks, we use this kind of scheme, placing the activation functions separately. And because sometimes there are quite deep neural networks with hundreds of layers inside, so we use functions to create layers. So first we place all dense layers, and then we apply the function that separates them with activation layers. Okay? Again, run your code to make sure that your code runs okay. If something wrong, then fix the errors. Okay, next thing, this is the finishing of our second lesson. So here is the activation layer which is placed as ReLU. We might change this rectify to yellow, to cello, to other types, and have a look of the graph that we obtained. So ReLU by default gives us the graph like that. So let's change it to yellow and run on the cell, and we can see that there are negative values, but the negative values are very shrink in those dimensions. Okay, and there are cello, and we obtain the graph that looks like that. Okay, so there are linear if they are positive, and there are some kind of less or more, I don't know, maybe more negative than the yellow. So there are different ones. We just in place those values, and we might use different activation layers to make our training of the neural network a little bit different. It might be longer but better, it might be faster, but so there are options. Okay, now very important part, let's train our neural network. So far we have just created the architectures, okay? But those neural networks haven't been trained yet. To train the neural network, it's very important to identify what loss function is. Loss function is the error that we will measure, and we'll try to minimize it. Okay, so here is the very common error, which is called the mean absolute error, or MAE, and it just measures the absolute values between the real and the prediction, between the real point and the prediction point. So we measure, sum up, get some number, and here is our loss. And if the loss becomes less and less, up until 0, then we somehow train the neural network and makes the line better and better. This is just for the table data. But once we talk about the classification data, there are different kind of loss functions. There are like sparse categorical cross entropy functions. Again, these are just the names for our course. We will use the name, and everything is done automatically by the Keras. Okay, so here's the error or loss function. And this loss function should be minimized somehow, and to minimize that, there is this specific technique which is called the stochastic gradient descent. So the computer calculates the derivatives and finds where the derivative goes, and identifies the value, the way where the function should go, where the function should go. If we go in the direction of the derivative, then the function becomes smaller and smaller in values, so it becomes finds the minimum. Okay. So this stochastic gradient descent allows you to find the minimum of the loss function, and we are going to create. Okay, so here, don't run this cell. It just shows you this GIF file, because if you run this cell, then you have to upload the file again, just to place it to content, and the file which I'm talking about, I haven't placed it. Okay, I'll place the GIF file for you. So this is just the process of training. Okay, it shows the process of training. Here's the real points, and here is like the line fitting these points, and it fits by training over the whole data, because the whole data might not be very big, and we won't be able to load it to the RAM of the computer. And if we talk about the images, then the graphical processing units are used for building those networks and training those networks. So the video memory is very limited, like 8, maybe 16 gigabytes, and for good values like Colab Pro allows you to use the GPUs with 40 gigabytes of video memory, and it's really beneficial. But still, you cannot load all data inside, so you have to divide them by batches. Okay, batches just like the part of the data. So here is the batches scene, and you can see that when there are batches seen for the whole data, your fitted line becomes really good placed on your original data. Here are how the weights are changing, something like that. So you will see these kind of pictures while you train neural networks. All right, so let's use the model.compile. So once you create the model, before that we created the model Keras sequential. This is our model. Then after we created the model, we used model.compile and place two options there: optimizer, which equals to Adam here, and loss, which equals to MAE. All right, so this is how we compile the model. And the third function that we are going to use, so model create, model compile, and then model fit. Model fit is just the process of training of the model. So let's try to create the model for red wine quality and train it. Okay, so first of all we have to read the data. We already done that with read wine CSV. Then let me make it fit over here. Okay, so here's the deal. So we have to create training and validation splits. This is a really common technique which we are going to use. Try to stay with me. df train. Okay, we are going to create. This will be some sample of our red wine. Red wine dot sample. And the sample will be like some fraction of that, of the whole data. Let's say that there will be 70% of the data. And to make all of us equal in values that we obtain, so we obtain the same kind of observations for the trained data and the same kind of observation for the validation data. We use the random state, and if we all use 0, then we all got the same kind of values. So df train is like that. Then we have to scale the max value will be our df train dot max, and unlike R, we have to provide some axes. So we are using the maximum values in our rows. Then the minimum values, df train min, df train min, axis equals 0 again, and creates the df train as the function, as df train minus minimum divided by the difference in maximum and minimum. Df train minus minimum divided by maximum minus minimum. So like that. And we split the values to x train will be df train dot df train dot drop. So the y value will be a quality of wine, so we drop the quality, and the rest will be our axis. And wine train will be df train quality. Okay, so here we have created the sample. We got 70% of the observations, placed them in df train. Then we calculated maximum and minimum and scaled our df train to maximum and minimum, like that. Then we separated x train and y train. Okay, so here we dealt with 70% of our observations. The same kind of thing will be with df valid. So we add df valid, and it will be red wine drop df train index, like that. So df valid is the same as red wine, but we subtracted of those 70% of observations. So the rest 30% of observations are in df valid. Once we scaled df train, we also need to scale df valid. We copy this line and change train to valid. Change train to valid over here also. Okay. And as soon as we created x train and y train, we also create x valid and y valid. Just copy that and change valid. Change here df valid. Change here y train to y valid. And df train to df valid. Okay. Okay, so max here is the, and here it should be like that. Over here, df underscore train and underscore valid. Okay. So pay attention over here and over here. Place underscore marked. So generally, this code you will copy for different data sets. If you have the different data sets like concrete, so here you'll have, instead of red wine, you'll have concrete and concrete. Then you drop the last column And the last column in the concrete data set is the compressive strength. So you, instead of quality, you place compressive strength, and that's it. And the whole code will work for another data set. Okay. Run this code, make sure that there is the green tick. And actually make photos because I need to go down to show a little bit. So previously we were creating the model for like that. This was our model. This was our model. So we are going to use this model for our task. We just copy the input shape. Make sure that this is 11 because I don't remember the input shape, which is placed. So here is our model. Next thing that after we copied that model, we have to compile it. So model.compile. Model.compile, and inside we place values for optimizer and loss. On above there is the example. So optimizer equals to Adam, one of the greatest optimizers here, and loss is MAE, mean absolute error. Okay, so this is the model compile. Make sure that your model have 512, 512, 512, 1, input shape 11, and model compile like that. So once you've done that, you run your history and you can see that there are epochs coming and the validation loss becomes lower and lower. That means your model is training. So your model trained for 10 epochs here. And we can see the graph of how your model have been trained. So you see something like the hockey stick. If everything is like that, then your model should be fine. And task number 3 will be task 3 will be your homework. Okay. Yeah. So the history code is already here. You model compile it like that. And to train the model, the function is called model fit. So in model fit, we place X train and Y train. We have created that, and X valid, Y valid, we have created. So this is 70% of observations. This is 30% of observations. We may vary these numbers. 256, we can place it 128, we can place it 64. If we talk about pictures, there might be lower numbers for pictures. And epochs we may change from, let's say, 10th to maybe 100, and run these for 100 epochs, and we can see that something is happening over here. Maybe the model is not that great. Generally it should be like that. So your loss will be like that. Okay.